All right, let's take a look at your day 2 worksheet. So 1 and 2, number 1, pretty straightforward. There's no need to rewrite sine squared as 1 minus cosine squared or anything. It's the only variable. It's the only thing you got. So just go ahead and move the 1 to the other side. Take the square root of both sides. Don't forget the plus or minus when you take the square root of both sides. And then you can solve. Number 2, again, already set up as a quadratic, so you just need to factor it. Make sure you factor correctly. Make sure you've got a minus 1 here and a plus 1 here. If you don't know why, try to FOIL this out, and you'll see that you'll get a plus 1 cosine in the middle, whereas if you switch these, you'll get a minus. So you've got to make sure that's correct. Okay, and then again, because this is a plus 1, you move it to the other side, you get a minus 1. So pi is the angle that has a cosine value of negative 1. 0 has a cosine value of positive 1. So we only want pi for that one. Number 3, very similar to 3 on the day 1 worksheet. It's already factored. Set both of these equal to 0. But then this is a cotangent. You want to rewrite that as tangent. This is a cosecant. You want to rewrite it as sine, except when you do that and you take the 1/2 and flip it, there is no angle that has a sine value of 2. So only this part of the solution is going to give you actual solutions. Number 4, I've got a cosine squared, a sine squared, and a sine, so I'm going to rewrite everything in terms of sine. I've already got 2 sines. I'm going to rewrite cosine squared as 1 minus sine squared, and now you should be able to solve that quadratic. Combine like terms, that's going to give you a minus 2 sine squared, so then you're going to move everything to the other side. Move everything to the right, and now you have a quadratic that can be factored and then solved. Five. So again, I had a cosine here, I had a sine squared. So I rewrote sine squared as 1 minus cosine squared. Okay, this sine squared is being multiplied by a 2, so you need to make sure the 1 minus cosine squared gets multiplied by a 2 as well. So that's going to get distributed. Over here, I distributed the 3, and then slowly I moved everything to one side. I moved everything to the right. This is 0 equals, again, that's another equal sign that did not scan very well. So everything's on the right. I could then factor, and then I could solve. Number 6, I had a sine squared on the right, so I took the cosine 2 theta and I rewrote it as 1 minus 2 sine squared. I used the double angle cosine formula, and I used the one where I could turn it into sine squared. Now, when you do that, you get a minus 2 sine squared, and you get another minus 2 sine squared. Those are going to cancel each other out and leave you with 1 equals 2. So your variables have just kind of disappeared on you. Whenever that happens in algebra, and you are left with a false statement, 1 does not equal 2, okay, then that means there are no solutions to this equation. There's no angles that you'd be able to plug in and get a solution. All right, on the back side, number 7, now, all I did was show my first step here. I moved the sign to the other side and got a negative sign. To solve this, what this is saying is that the cosine of the angle and the sine of the angle are actually opposites of each other. This is a positive and this is a negative. The 2 quadrants where sine and cosine are opposite of each other is quadrant 2 and quadrant 4. That's where these 2 angles came from. But I could have shown a few more steps here. I could have done this just like the day 1 assignment, number 7. I could have divided both of these by cosine, and that would have turned this into a tangent. It would have been a negative, and so tangent is negative in quadrants 2 and 4, and you would have got those angles that way. So I probably could have showed a few more steps on this and done it that way. It would have been a little easier. Number 8, I took the double angle, sine double angle, and I replaced it with the double angle formula. Now it looks like that didn't get me anywhere because I still have sines and cosines. However, I have 2 terms that both have the word cosine, so I can factor that cosine out. I can then set cosine equal to 0, or I can set 2 sine theta minus 1 equal to 0. These two mini equations, this one only involves cosine and this one only involves sine, so I can solve each one of those individually, and this one has 4 different angles that are solutions to that equation. Number 9, I had a sine and I had a cosine squared, so I rewrote the cosine squared as 1 minus sine squared, and then I had a quadratic with just one variable to deal with. Number 10, I rewrote sine squared as 1 minus cosine squared so that I would have everything in terms of the same variable. (11) was already set up. I just had to figure out how to factor that. Now, when I did factor this, this is not going to give me a solution. When I solve this, I'm going to have the inverse cosine of 4. There is no angle in the world that has a cosine value of 4, so that's not going to give me a solution, but these two are going to be solutions. And then number 12, I distributed my 4, but I also rewrote cosine squared as 1 minus sine squared. So then I would have everything in terms of sine. I moved everything to one side. I factored correctly. This factor does not give me a solution, but this one does. So this one only has one solution, 3 pi over 2.